Hey guys, so today I just wanted to talk about how to overclock your Ryzen 3600 processor. This is going to be the 3600 non-X CPU. Um, and this is kind of a heated debate online, Reddit, a lot of forums out there, you name it, regarding like the safe voltages for this processor. Some say that they have been running the processor for 6 months, whatnot, at 1.4 1.5 volts, and there's been no degradation at 4 gigahertz, or 4.4 gigahertz, 4.3 gigahertz, whatever. And others say, well, you know what, that's too high voltage. Some claim that even 1.3 volts is too much. Others suggest sticking to 1.28 volts, and take it as far as you can, as far as the frequency with that type of voltage. The truth of the matter is, and I don't care what anybody says, and this is just from having several 3600 processors, and this is from my own experience. What I have, matter of fact, found out with this processors is that what really matters is it's really what die you get. It's just it's a what they call silicon lottery. So it really all depends on which CPU you get, what part of the wafer it was taken from. I have some processors that will go up to 4.2 and it would not overclock past that, no matter how much voltage you throw at it, where you set your low and light calibration, where you do anything. Others go up to 4.5, like the one that I have here. It'll go up to 4.5 at 1.35 volts. Which is great. It'll do 4.6 at 1.45 volts, but that's a little bit too high. And as you're about to see, heat is really the limiting factor for overclockers. Obviously, again, it depends also on the silicon quality. But if your processor can overclock, it is a good overclocking processor. It can do 4.5, 4.6 gigahertz, but you're starting to see that it passes, for example, Cinebench. It'll run a Cinebench benchmark just fine, but then when you run Prime 95, it will crash. And you're trying to figure out why that is. Well, number one, Cinebench is not a stability test. This is just to get some reference numbers as to how your CPU overclocking, your frequency is doing in comparison to your previous run or others that are pre-listed there on the app. If you want to test for stability and you want to know if your CPU truly is stable, Prime 95 is a good choice. However, this is kind of an unrealistic scenario. This right here, this is an abomination, okay? Which it is a necessary evil, because if you want to test for stability, and you know what you're doing, you know how to use this app, this is very helpful. Unfortunately, a lot of overclockers that I have seen, I have read in forums, they try Prime 95 and they soon find out that their system is not stable. And so they go and drop the voltages, and that doesn't work. They go and drop the frequency, that doesn't work. But what I want to point out today is really that the real reason for instability. The real reason for instability is that, this is what I have learned myself, is heat. It's just heat dissipation. We don't have currently in the market AIOs that can tolerate the type of overclockings that a lot of us are doing. There just isn't. I can run this stable, and I mean stable by Blender loads, video editing, decoding, whatever, whatnot, perfectly fine, 24/7. Whatever I throw at it, whatever real life scenario that pushes my CPU, any AVX load, it will run it just fine. Finish the load, no crashes, no funny business, run my games perfect, just normal. But as soon as I turn on, or as soon as I run Prime 95, boom, it'll crash. And I will show you, I'll give you an example right now as to what I am talking about. All right. By the way, this is an application that if you're thinking about going, taking this this adventure, this is an application you must have. So you know what? Let's just go and start with that. First, if you want to download Prime 95, check out Tech Power Up. Download it from there. Hardware info, you can download the installer or the portable. I stick with the portable. You can also donate. I mean, this is a great tool. I give to them when I can. And two things. You should download Blender, even if you don't use it, even if you don't do any video editing of any kind, any sort. Download it, because this is really helpful to have. With this application, you can run video editing scenarios with benchmarks that you can download. For example, like this one here. Download this, and what you would end up getting is something like this here. So let me just run this here real quick. Minimize this, and you can run this benchmark. And see, this will do it for you automatically. It'll do the BMW, Coro, Classroom, blah, blah, blah. Obviously, I don't want to run this just yet. You can also download this one here that runs straight out of the program. So that's why I advise you to download the program and then also download the benchmarks, because there's a few of them that are handy to have, just to have them, just to run, be more confident about your system being stable. Okay, so we got hardware info, and I think I covered what you need here. So it's just these four things here: Prime 95, hardware info, and the Blender benchmarks. And the reason why I point this out is because this is more real world performance. This is more real world stability, as close as you can get without actually having to learn the whole program and going through the learning curve. So yeah, anyway, no more mumbling around about that. So, okay, so we close this out. And when you open hardware info, let me do that again. And by the way, this is for those of you guys that are, learning and kind of new to this stuff. Some you guys that are more advanced and know what you're doing, I'm not talking to you, because obviously you probably wouldn't even be watching this video. So, but anyway, you just scroll down here. Don't pay attention to any of this stuff here. I mean, yes and no, you can look at that stuff later, but what you want to focus on, if you want to learn your CPU and how to overclock it, how high it can go, you want to scroll down here towards the middle, and you want to have this here. Okay, this is very important information, and I will show you why right now. All right, so we're going to run, and by the way, my CPU is not overclocked. This is stock settings. The only thing that is overclocked is the Infinity Fabric. I have my memory currently running at 3800 megahertz. So I have to have my divider at 1900. So that's the only thing. But as far as like frequency, everything is a stock, just out of the box. Right. Let's run Prime 95, and I want to give you an example of what I'm talking about here. Let's do small FFTs. This is even more stressful, but for this is enough here. This should be plenty of overkill, really. So we'll set this aside here. And if you don't want to see all those windows, with each thread popping up, just go here and check these boxes. Just have this here. Okay, and you get everything in one box. And you could probably hear already my fans are spinning up. Yeah, we're not going to get any information like this, so we need to kind of drag this in. Sorry about that, guys. I've forgotten that my resolution here changed when I go to my my capture card. Yeah, it's two different resolutions. This is 1080p, and my daily system is 4K. So anyway, so this is the voltage here that you want to focus on. Focus on this voltage and this temperature. This is your die temperature. So this is as close. By the way, this is the best program that you can use. Make no mistake about it. This is as accurate as it can possibly get, software-wise, without using thermocouples or voltage, probes or anything like that. So right now the processor is running at 76 Celsius at 1.3 volts, say, okay, fluctuating between 1.31, 1.32. And if you want to refresh, you see how this is refreshing this fast? You go here, you change that to, if you wanted 200 milliseconds, you type that in and then you hit set. Because if you just type 200 milliseconds and then you close the app or whatever, or hit OK, it's not going to save that for you. So that's what you would do. You just change this. Let's go to 100. Okay. Okay, now it's a little bit faster, as you can see. So yeah, and we're at 103 watts. Okay, so this is normal. But here's the thing. And remember this, if you want to overclock this and you want to know where the true, or how should I say this, the most realistic and the safest way to do it, okay, if you want to have that peace of mind, this voltage that you see here, this is what the system, what the VRM, what the CPU, just the whole system in general is working to have a stable system, to have your computer running. This is what AMD, the motherboard, is suggesting. Okay, hey, this is what you should be running at according to this. Okay, so the system will keep pushing, and it'll, and if you're doing this manually, it'll take it up to that voltage, and it will use that voltage that you gave it if this is safe. If this is too high, it will begin to downclock, or not downclock, but that also, yes, but it will begin to undervolt itself to protect the CPU, which is a good thing. This is a safety measure. So you begin to notice that eventually, as this creeps up into the 80s and starts to go into the mid 80s, you will see that this voltage here starts to drop to 1.3, and then 1.29, 1.28, and then suddenly your manual overclock becomes unstable. That's just how it is, and you will see your computer crash, and then you're wondering, like, why did that happen? My CPU, I guess, is not stable at 4.4 gigahertz. It may be stable at 4.4 gigahertz. It's just that your cooler is not good enough, because the system is set to automatically protect your CPU, so it's going to downvolt itself. That's just how it is. Now, if you manage to have this, for example, in the 70s at a manual overclock, the voltage will be pretty much static. The system will do, again, depending on your CPU and the type of VRM you got. If you got a pretty decent motherboard, and you have your low line calibration set correctly, then this should be okay. You shouldn't see too much fluctuation here, because you want to have a pretty steady, a consistent voltage. You don't want it to be fluctuating too much, because then it's just everything goes to heck. So based on what I see here, and just running it for a couple of minutes, and I know there's more FFTs coming, more instructions coming, but just to get a starting point, kind of like a baseline, a quick baseline, I would say that 1.3 volts is my safe voltage for the CPU. Okay, this is the voltage that, according to my temperature, this is the voltage that this CPU will tolerate. This configuration, this silicon will tolerate, and still give me these kind of temperatures. So okay, that's my baseline. So this will be the voltage that I will utilize to find my highest frequency. So I will set it between 1.3 and 1.32, okay, in that area, because as you can see, it does fluctuate here. Okay, and it's just bear with me, guys. I mean, as you're starting to see the temperature go up, the system is doing what it can because it does have some headroom. So according to the load that the Prime 95 is putting on there, it'll keep going if it has the headroom. But once it starts hitting the 80s, you will see that this number here will kind of reach a limit and just hit a wall. It doesn't want to go past that. So the hotter this gets, yeah, well, I think you understand what I'm saying. So I'm going to stick to 1.32, 1.30, okay? That's going to be my number. All right, so, and the reason why we're doing this with Prime 95, I forgot to mention, is because you want to test this, you want to find this baseline doing a worst case scenario, and you want to use this thing here, this abomination, what I call, because this punishes your CPU and just throws unrealistic loads to it. Like, this is just something that you won't see in a, you know, I don't know what you will be doing to be able to push it this hard. I have no idea, but very unrealistic. But at the same time, it's necessary. It's very useful if you're overclocking. All right, so 1.32, 1.3 volts in that area there. Let's go ahead and stop the test here. And if you wanted to go further, you can, you know, but I have done that. It makes no sense. As long as you have a pretty decent cooler, you should be just fine there. All right, so you got your tools already downloaded. You already figured out that your safe voltage will be 1.32, between 1.3 and 1.32. Okay, so you got that already taken care of. All right, so hopefully I think I'm covering everything here. Let's go ahead and reboot the system. Go into the BIOS. All right, so we're in the BIOS. And what we want to do at this point is, let's see, we want to I think we'll go slowly. We'll go to you know what, let's see, 4.3. It boosts to 4.2. that's what this thing does, with turbo boost enabled. But let's try 4.3 just for the video. I know I can do 4.5, but just for this here. And we don't want to leave the voltage. If you're going to be overclocking, you don't want to leave this on auto, because it'll just overshoot the voltage to some insane, ridiculous number, and you don't want that. So offset, I don't care for that. I'm just going to go with let's see, as we said, 1.3 volts. Okay, we'll set it at that, and that is our baseline. That's the number that we decided. So if this is not stable at 1.3 volts, then we go to 1.32. Okay, we won't touch the low line calibration right now. We'll leave everything alone, and then we'll retry the test. All right, so now let's pull up hardware info. And I don't have low line calibration enabled, so this is a pretty decent motherboard. This is the MSI P550 Unify X. The VRM here is a monstrosity. It's really good. So if you don't know about it, I'm not going to get into all the details. You can look it up yourselves. But it's a good VRM. Okay, so as you can see, I got my 1.3 volts. That's what the system decided it's going to be our safe volt, according to how good our cooling is. Okay, how cool the processor was running. Again, but I want to also stress that even though you do have pretty good cooling, again, the silicone lottery plays a big role here. You may be able to run it at 60 degrees, but if your your die, it just sucks. It's just terrible. It doesn't matter what you do, you're not going to get, perhaps 4.3 or 4.4. That's just how it is. But if you get a good one, a decent one, then yeah, this is for you. So anyway, all right, so here's our system on idle. Let's pull this back up. Now this might crash because I don't have low line calibration. So you will see our I'm not saying that it will, but it might, because you will see our voltage is kind of going all over the place. That's just how it is. So let's go. But it should be pretty stable. Okay, so we're now at 80 Celsius at 1.29 volts. Okay, so, and I think this will be pretty static until the next load of FFTs come up. Then it'll push harder, at which point the system will detect, if it has a little bit of headroom, it'll go up on the voltage. But at 80 Celsius, it's more like, yeah, not too promising. So yeah, this is pretty promising. This looks good. And for having on low light calibration on auto, this is actually, I'm pretty impressed. That it's holding the voltage where it is. So and by the way, this test here, if you want to be sure that it is stable, you want to let this run for at least 20 minutes. I don't think that you should be running this for more than that. It's just really unnecessary. Some will swear 2 hours, but really, no, I don't think so. So bear with me here. I just want the next FFTs to come up. And we're still holding strong on our voltage. Which is pretty good. With this CPU here, if I run this at 4.5 gigahertz at 1.35 volts, like I was telling you earlier, it'll run just fine. It can be a daily system, a daily overclock. The problem with that is that the cooling is not good enough. As soon as I start this test, you will start seeing this going into the 60s rapidly. 60s, 65, 70, 75, 80, 85, and then it'll shut down. And you also see my voltage drop. So that's telling me that the CPU is saying, okay, I had enough, time to go to sleep. But if my cooling was good enough for that overclock, then yeah, I don't doubt that it would have no issues, because I can run the CPU at 4.7, again at ridiculous voltages. I've had it go up to 4.7 at 1.55 volts, which is really just insane. But it'll run 4.6 at 1.45 volts. Again, my cooling is not good enough, and I can't find anything reasonably priced other than custom water loop, which I'm not going to do that. That's just not what I do. Yeah. But anyway, by now this would have crashed with my 4.5 gigahertz overclock. So it would have crashed a long time ago. So this is telling me that with that voltage, as you can see, that voltage, that is enough to hold 4.3. Where's my 4.3? And you can see it there, static. So yeah, everything looks good. I just just want the next FFTs to come up, and I think I'll speed this part of the video up. Okay, so at this point we're already at 5K, and yeah, it looks like everything is pretty stable, and it appears that 1.2 or 1.3 volts is enough to hold that overclock without any crashes, without any overheating, any issues. So I think we can call this, again, 20 minutes is what I recommend, but for the sake of the video, I mean, yeah, if this was unstable, it would have crashed already. 20 minutes is just to be like very, very sure, you know, not 100%. It's never 100% with these things. That's the reality of it, but this will give you a better peace of mind if you let it run for 20 minutes. But yeah, okay, I think I'll stop it here, reboot the system, and go up. Just want to see how far I can get. Alright, so now let's try. Let's see here. 4.4, and we're not going to touch the we're not going to touch the voltage. We're just going to leave it there, but I do want to kind of, yeah, I want to set the load line calibration here. I want to set it to say 4, because you do want to have some V droop. It's better for the transient response between the VRM and the CPU. It's just yeah, so we just want to set it there, and I think that's it. So let's go ahead and reboot. And if your system doesn't reboot for whatever reason, what you would do at this point is flip the switch and back your computer on the power supply. Reset your BIOS, and then start over. Okay, so let's go ahead and get hardware info. Okay, so now we're at 4.4 static. And also, don't forget your make sure that you do have the AMD chipset drivers, because this allows you to have your AMD Ryzen high performance power plan. So you want to have this enabled. Okay. All right. So we're at 1.3 volts, and we have a load line calibration of 4 on my MSI BIOS. So everything's looking normal. Now let's see if that holds with Prime 95. Say 4.4. Yeah. Okay. All right. Here we go. So you see the voltage kind of drop a little bit there. That's because I give it a little bit of V droop. May have to go to number 3 to be able to hold this frequency, because now you see the temperature starting to go up, and this is going to go down. And also, if the system senses that the temperature is too high, it is just going to halt completely. So again, that's not a bad thing. It is actually a good thing. So yeah. All right, so we just let her run. And I'm sorry about the noise in the background. That's my wife, yeah, fighting with my son. Okay, so as you can see, like even at 4.4, the temperatures are remaining in the high 70s because the voltage is, you know, where you set it. So it's all linked. And my wattage, my power consumption, your power consumption will also go up. So yeah, that's expected. But I think I need to go to 1 point. I need to raise up my low line calibration, because I remember, if I remember correctly, this was not stable here on Prime 95. So it might crash any second. This needs to stay at 1.3 volts or 1.31. I might be wrong. I think this was the CPU that I had that, I don't want to say issue with, but that was the case. But then the temperatures are holding pretty good, so that doesn't seem to be an issue. But then again, if you don't give it enough voltage for the frequency that you're trying to aim for, then obviously it's also going to crash, because it's just not enough power. So see how it's all correlated. So yeah, that's just how it is. Correlated, is that even a word? I don't know. And another thing I wanted to talk about is that if it does pass this test, like if you let it run for 20 minutes and everything checks out, your voltages seem stable, your system is stable, the next thing you would do, step 2 for stability test, would be to run the blender test, the blender benchmark, and run all tests, I think it's like 5 or 6 of them. Let them just run. If you see that for whatever reason the system crashed, it was not stable, then maybe you can try going up. For example, if you're at 1.3 volts, you can try to go to 1.32 volts, rerun the test again. If it fails, what that's telling you, it's two things: either your system is reached its tolerance as far as temperature, or that's just as far as your CPU is going to go. Your die, the silicone lottery, for example, that's just as good as it's going to do. So no matter how much voltage you throw at it, it's just going to keep crashing on you. Or you could try better cooling, but if it's staying in the low 80s, high 70s, low 80s, it shouldn't be an issue. I believe this thing can go up to 95 Celsius, but you don't want to go that high. It's just, yeah, that's a good way to quickly degrade your CPU, and just, yeah. In a few months, what used to do 4.2, now it's doing 4.1, for example. That's what could happen. You know what? I want to try to even push this harder. Let's go for the harder test, and this might crash it. If it's gonna crash, it's gonna be this one here. Let's do it. All right, we're at 81 Celsius already. 82. Oh boy. And this would be an impossible test at 4.5. Like, it would insta crash. As soon as I turn this, like I try to run this on my 4.5 gigahertz overclock, it would insta crash. See, there you go. That's what I was talking about. Okay, so we got our first error. What that's telling me is that this here, it's not enough. So what we could do is try to rerun the test, and with a little more voltage, and well, there you go. That's a perfect example of what I'm talking about. So what we want to do is I think Mode 5 is where I had it last time. Yeah, I think it was mode 5. And let's try 1.32 volts because that's kind of like where it was hovering. Or you know what? Let's just leave it there and see what the low line calibration does, yeah? Yeah, I think it's on MSI, that thing that low line calibration is backwards. I think 1 is like the highest and 10 is like, or 9, I don't know, I don't remember. 9 is like the lowest. Alright, so let's try that again, and we're at 1.3 volts. And we'll skip this one, we'll go straight to the most dangerous one. Alright, let's go. Yeah, that was the... Yeah, that gives it even more V-droop. Alright, you know what, let's just stop the test here. Because I got errors right away, you saw that, right? We'll do low line calibration 3. And I want to do 1.31 volts because that's where the system was hovering automatically. So 1.31, we'll do low line calibration 3. And I'm not going to touch anything else. I'm just keep it simple, you know. Alright, so let's go ahead and reboot the system. Okay, so let's start hardware info. 4.4. And now we're at 1.31. Let's start our test. See how quickly the temperature goes up. Okay, if you don't have the proper cooling, this will easily creep up into the 100s or like the high 90s, and your system will just like crash right there and then, and you're wondering why that happened. And it's not that it's not stable, it's just that you don't have the proper cooling. Well, yeah, it's not stable, but it's not because you're doing your overclocking wrong, it's just that you don't have the proper cooling. And this thing climbs up too fast for your cooling to pick up, for your fans to start winding up fast enough to keep your system cool. So yeah, that's what's going to happen. Alright, but at least it's not insta crashing, or we didn't get the immediate error as we did the second time around. So yeah, we're in the high 85s now, and this is where I would feel comfortable. Like I wouldn't want to go any higher than this. And because of the temperature, this may not be stable. It may be stable if I had better cooling. Like there's probably no issue with this voltage at this overclock, at this frequency, but the temperature might be the issue. You get what I'm saying? So because yeah, you see it's climbing up, and as it start, and when it goes into 5K, oh man, this will go up a little higher too. But now I do feel pretty confident that this is my number. Even if it crashes right now, even if this fails, I know it would be because of the temperatures. There's just yeah, it will spike, and we wouldn't even have a chance to see it here, like for hardware info to pick it up, and that will cause the crash. But I will feel pretty comfortable now running at 4.4 as a daily system, running like the most intensive real world applications like Blender, what other video editing programs out there, games, and light loads like that. So it's going, and this is like the most torturing program that I know of. Like it's in this setting, unless you want to do customs, you want to throw 128K FFTs, then yeah, you could do that, but I don't want to do that. So yeah, that's on you. You can if you want to. And yep, it crashed again. So I am pretty confident that 85 is like the borderline where this just doesn't want to go any further than that. If I had better cooling, I know that it can do that, because I have tested it with Blender. It runs all benchmarks just fine. It doesn't crash with any other program, nothing except for this heavy test here. And it only reaches this temperatures with this test. So I know the temperature is my issue. That's what's holding me back and what's causing my crash. But the system too is just basically halt. So I think I'm going to leave it there at 1.31 volts at 4.4 gigahertz, and low light calibration 3, and that will be my daily system. That's just how it's going to be. Alright guys, so now let's go ahead and run a Blender test. First let's pull up hardware info. And I'm gonna keep it at my max, what it was fluctuating between 1.3 and 1.33 volts. So I'm gonna take it to 1.33 volts and I'm gonna leave it there. I have set the low line calibration to 3. So yeah, let's go ahead. Everything looks good. Yeah, let's go ahead and run the Blender test here. And by the way, none of these here are my creations. I'm not taking credit for this here. So this is not my stuff. If you care about who the creators of these renderings are, you can go to the Blender website and get credit to them. You can donate, I'm pretty sure, but I'm not claiming these as my own property because they're not. So alright, we'll let this run here. It takes about 10 minutes, so we're gonna speed this process up here, so as to not make this video longer than it already is. Oh, and also before I forget, I also wanted to point out that this test will utilize up to 20 megabytes, or not 20 gigabytes of RAM. So I have 32 gigs, so yeah, it will utilize as much memory, or 20 gigabytes. It will utilize 20 gigabytes. So if you have 16, it'll end up maxing out most of that. So yeah, 32 gigabytes is what I got. It's what it's using almost 20. So yeah, just wanted to throw that out there. Alright guys, so it completed the test. So it'll keep going in the loop if you let it go. So this is something that you have to kind of stop because it just takes too long. The importance of this test, by the way, is that not only does it give you a real world performance test of your CPU, but it also stresses your memory because it'll utilize, if you have 32 gigs, it will use about 20 of that, like I said. And if you have 16 gigs, well, yeah, self-explanatory. It will utilize most of that. But it also stresses your memory controller. It'll stress your Infinity Fabric. And if you are overclocking your memory, this is an excellent test because it'll just stress everything. And as you've seen, it doesn't put that unrealistic, I want to say unrealistic load that Prime 95 throws at your CPU. This is what you can expect in real life scenario. But another, I threw this one in there because it's like the one that will cause my system the most problems until I finally got everything tweaked out where it's just, past everything. Or it was just stable. But the benchmarks here are also pretty useful. I found myself running into a lot of walls getting my system to be stable, and finally figuring out what I had to do, my way of doing things, and what worked for me. But this was very extremely helpful, these benchmarks here. So yeah, just let that run. But to drive the point home, Prime 95, test your temperatures, find your max safe limit for your CPU voltage, where you can, that you can go up to play with your frequency, and the blender benchmarks here for testing your CPU overall, system overall, and these here, by the way, before I forget, this one here will just mainly focus on the CPU. This one here will test everything, like RAM, memory controller, and Infinity Fabric, just like it would on a daily, everyday basis if you were doing video editing. So yeah, it's punishing. But this one is mainly for the CPU. So if you just want to focus on the CPU, you're not worried about your memory because you're not overclocking your memory, then don't worry about this one here. Or you could running, it's up to you. But yeah, that's just how I do it, guys. This is what works for me. It's proven to be fail-safe, and I have been doing this, and I finally got it to where it is, and I learned so much like this for the last wow, man, ever since the 3600 launch. This is how I've been tweaking it out. There's other settings in the BIOS that you can obviously do as well, if you want to gain a little more stability. I'm not going to go into that in this video. I can, if per request, if you guys want to, I can do that in a future video. But I think, as you've seen, this is just what works for me, and it should work. The methodology should work across all platforms that are overclockable. So if you have a motherboard that overclocks and lets you overclock your CPU and has a decent VRM, you can use this methodology to test your CPU and whatnot. Your results may vary because, again, you're, like I've been saying, it depends on what type of processor you get, your motherboard, your setup, so the cooling that you're using. So you have to take all those things into account when you do this. So that's why you run Prime 95, find your max voltage, temperature, and go from there before you start overclocking, that is. But anyway, I hope this video was helpful, guys. I hope it made sense. I hope I didn't mumble too much. I tend to do that a lot, so just yeah, you're welcome to give me any feedback. I welcome that, and I know I'm going to get it in the comments because everybody has their own way of overclocking. Everybody has their own opinions. I get that. This is just what works for me. Do it your way. Throughout the years, this is just how I learned to do it, and I don't care what anybody says, really. I know this is what works, so yeah. Yeah, anyway, hope you enjoyed the video. Please hit thumbs up if you liked the video. If you didn't, you know what to do. Subscribe for more content coming up, and I'll see you guys in the next one. Take care.